Having to mow your lawn on a hot summer day is a thing of the past now that Greensea is working alongside Georgia Tech to remove this heavy chore. In today's world, people and companies lack the time and resources needed to manage their lawns efficiently because it is a very labor-intensive task. From a commercial viewpoint, many commercial landscapers want to reduce the cost of labor and improve the quality of life for the mower operators. On the other hand, many residents lack the time needed to physically mow their lawns. The global market shows that lawn care is a $28.5 billion industry, where the majority, $16 billion, is towards residential lawn care. We also see that the robotic share and electric share will grow up to 11% and 5.9% respectively by 2027. This indicates that the market for autonomous lawnmower is greatly desired and growing at a fast rate. Specifically in America, landscaping companies have grown to approximately $14 billion in the last 5 years, as shown by this graph. Now, let me introduce you to the engineers that are going to revolutionize the lawn care industry, Team CapDesign. My name is Nabil Koja, and our team consists of Nachiket, Kane, Joseph, Harsh, and James. We are working on the autonomous lawnmower project sponsored by Greensea. Although there are existing autonomous lawnmowers on the market, they have failed to meet the customer requirements and expectations. A prime example is a Roomba-type mower. They come with many drawbacks, including the need for a boundary wire, and they are ultimately inefficient. It is evident from today's society that there is a strong need for an autonomous lawnmower that will free time from tedious, labor-intensive work, leaving more time for productivity and innovation. After having a sit-down with one of the largest commercial lawn care companies, Brightview, we have learned that lawn care companies prefer to have gas-powered mowers over electric mowers because they overall provide more power, runtime, and speed. We considered these remarks during the ideation phase, which has helped us come up with our final design. This is our final design and solution to your autonomous lawn care needs. As you can see, we've incorporated a control panel housing several electronics such as a battery, a D455i Intel camera, which has a built-in IMU or inertial measurement speed encoder, RTK GPS, and a ruggedized computer. On the control panel, we see that there are 4 modes of control, which are on, map, mow, and cancel. The map feature is particularly important because this is how we will record the path the lawnmower takes. This will be further explained in our simulation. In addition, for safety purposes, we have implemented an emergency stop button, which is located at the top of the control panel for ease of access. Moreover, our final assembly incorporates a robust braking system which uses 2 DC motors, a mounting plate for the motors, 2 caliper brakes, and wires connecting to the components. The wires are not shown in the CAD, but essentially the calipers will contract on the left and right wheel to aid in controlling the variable speed as well as its turning capabilities. If an obstruction is in front of the lawnmower, the D455i camera will detect it and send a signal to the DC motors. That will initiate the contraction process of the calipers so that the wheels will be halted to a full stop. Lastly, caster wheels are an important feature to add on to the lawnmower because it allows the user to achieve zero turn capability and at least 10% overlap. Thus, it will be easier to achieve more precise pattern cuts. Encoders are attached to the rear axle, which reads the angular speed of the wheels. This information is relayed back to the ruggedized computer, which is housed in the control panel. Through a control loop, the variable speed of the wheels can be regulated. Next, here's a video demonstrating an exploded view which illustrates how the components attach onto the lawnmower. Our state-of-the-art navigation system allows our mower to trace the user's predefined path while in map mode and computes the most efficient routes for maximum mow coverage. Using the onboard cameras and GPS tracking, we can create a 2D representation of the lawn represented as a cost map. In this cost map, physical obstacles have infinite costs such as the gray cylinders shown on the left. Our navigation system allows a global planner that algorithmically plans the best path for efficient obstacle avoidance and maximum mow coverage. These calculations are shown on the right. Lastly, we see how the turtle bot on the left, shown as a black figure, orients itself and translates in the path designated for it. Please call 1-800-CapDesign to be the first ones to own this revolutionary technology. Let's make life simple.